Today we're doing 2.6 solve factorable polynomial inequalities algebraically. So your goal today will be to determine the solutions to polynomial inequalities by factoring them. Okay, so the difference between an equation and an inequality is very simple. An equation has an equal sign and an inequality has a less than or equal to or greater than or equal to an inequality sign. And the method for solving an equation versus an inequality is quite different. All right, so a linear inequality is actually quite simple to solve. You've got something like this, which is a linear inequality because it has this sign, and linear because it's degree 1. And all you do is you use your grade 9 algebra and you rearrange and isolate for your variable. So in this case you would have x is greater than or equal to 4 plus 7 and x is greater than or equal to 11, and you show that on a number line by, let's say, saying this is 0, this is 11, and have a filled in dot, and you're going to go this way. That's simple. Now, the other important thing to know when you're solving linear inequalities is that if you divide or multiply by a negative number, you must flip the inequality sign. So that comes up in this example. When I'm starting to rearrange this, I would get negative 2x is less than 12 plus 4 when I move the 4 over, minus 2x is less than 16. When I divide through both sides by negative 2, I get x is greater than negative 8 because I have to flip this sign. So this would be negative 8, so there's 0, there's negative 8. It's greater than, so we don't have a filled in dot, and then we're just going this way, of course, on our number line. Okay, so solving linear inequalities is really not difficult. It gets more complicated when we try to solve polynomial inequalities. So the steps are, number 1, factor the polynomial to determine the zeros. And then 2, use intervals and arbitrary test points in the interval to determine your solution. So you'll see what I mean in a second. So the first one, solve each inequality. Well, x plus 3 times 2x minus 3 has to be less than 0. If I were to graph the polynomial p of x equals x plus 3 and 2x minus 3. Now, you're not asked to graph it, but if I were to graph it, I know a few things about this polynomial function. I know the leading coefficient is really 2, which means that it's positive and it opens up. I know the zeros are at negative 3 and at 3 halves. And I know this is a quadratic. So it opens up, it's a quadratic. I don't know where the vertex is, but I don't care. So that's what it looks like-ish. And so what this is saying is this polynomial has to be less than 0. And if we look at our graph and we start going from left to right as per usual, where is this graph less than 0? Where are my y's less than 0? Well, as we move along from negative infinity to the first 0, we can see that our graph is always above the x-axis, which means it's positive. Between negative 3 and 3 halves, the graph is below the x-axis here, which means that the graph is negative, with negative meaning less than 0. And from 3 halves on to infinity, of course, we can see that the graph is above the x-axis, which means that it's positive, greater than 0. So this sign here is telling us what we're looking for. We're looking to see whether the graph is negative. Less than 0 would be negative. Greater than 0 would be positive. Okay? So we first have to factor it, if necessary, to determine the zeros. Well, you can see that it's already factored for us. So let's just find the zeros. So I'm going to go with x plus 3, I'll just rewrite it out, 2x minus 3 is less than 0, and my zeros are x equals negative 3 and x equals 3 halves. Okay, so I am going to use those zeros to make up my intervals. And I'm going to start by going left to right again. So my first interval is going to occur from negative infinity to the lowest zero, which in this case is negative 3. And we're going to go with round brackets here, okay? And we're going to continue on. So from negative 3, the next interval occurs at 3/2. Because remember, a sign change doesn't necessarily occur at the zeros, but we know at the zeros it's not equal to 0. So we need to keep the round brackets here. And then we have the last interval from 3/2 to infinity. Okay, so now what we're going to do is we're going to have these arbitrary test points. Just pause the video for a sec. Okay, so we are going to use arbitrary test points then to figure out what whether the factor is positive or negative in that interval. So my factors here, I'm just looking at my function, and I'm breaking it down into the two factors. And then the next one would be the result of the two factors being multiplied together. So this is just really our polynomial function, right? It's x plus 3 times 2x minus 3. All right, you'll see what I mean in a second. So we're going to pick a value that falls within this interval. So always pick like a big one, and I would say something like negative 100 might work. So if I'm substituting into the factor negative 100 for x, I'm going to get a negative value. Negative 100 plus 3 is negative 97. If I put in negative 100 here, 2 times negative 100 minus 3, that's also a negative number. And when I multiply these two factors together, which is what I do with this polynomial, I get a positive. And so I know that I'm looking for this polynomial to be less than 0. If it's positive, it's greater than 0. So this is not the result that we want. So I'm going to move to this interval now. I pick a number between negative 3 and 3/2, not including negative 3 or 3/2. Let's pick 0 whenever possible. So 0 falls within this interval, and I'm going to say 0 plus 3, that's 3, that's positive. 0 times 2 minus 3, that's going to be a negative result. And when I multiply a positive times a negative, I get a negative. This is the result we want. We want our polynomial function to be less than 0. So we know that in this interval, our polynomial was negative, and we can verify that with our graph. All right, so we've got the last interval, 3/2 to infinity, and we know that 100 falls within this. 100 plus 3, that's positive. 2 times 100 minus 3, well, that's still positive. A positive times a positive is a positive, and we do not want our function to be positive. We want our function to be negative. So we're going to say no to that one. So we know, and we already knew this when we graphed this and looked at the graph. We could see where the graph was positive and negative. But I'm not going to ask you to do it by graphing. I'm going to ask you to solve using this chart method. And there's a very good reason for asking you to do this, because in the next chapter, when it gets more complicated, we are going to use this method again. So this is a way of sort of forcing you to be comfortable with this method before it gets hard. Okay, so therefore, let's see, what did we have? X plus 3 times 2x minus 3 is less than 0 when x is an element of negative 3 to 3/2. Round brackets, because it was not allowed to equal 0, it had to be less than 0, so it couldn't take on the value of the zeros. Okay? All right. So let's go to a little more complicated one. So this one is saying, this one is saying, solve this one. We want this polynomial, we want to know the intervals when this polynomial function is greater than or equal to 0. So good that there's a 0 on this side. If there weren't, we would have to rearrange things to make one side 0. And now we're going to do our factoring, and unfortunately it doesn't work by grouping, so we're going to have to use b equals plus or minus 1, plus or minus 2, plus or minus 3, etc. I'm just going to do the first 3. And then plus or minus 1, plus or minus 2. B over A then is going to be plus or minus 1, plus or minus 1/2, plus or minus 2, plus or minus 3, plus or minus 3/2. Okay, some options there, but I can see from looking just at the coefficients here that 2 plus 3 minus 17 plus 12 is 0. So I know that P of 1 equals 0. So x minus 1 is a factor. I'm going to use my synthetic division. So this is minus 1, 2, 3, minus 17, and 12. Bring down the 2, negative 2. Subtract, that's 5. That's negative 5. Subtract, that's negative 12. Multiply, that's 12. Subtract. Good, we get a remainder of 0, so we know x minus 1 is indeed a factor. So now, what do I know? So far, I have that x minus 1 times 2x plus, squared, plus 5x minus 12 is greater than or equal to 0. So I've just put this polynomial in a different form, that's all. And now I have to factor that, so I need to find two numbers that multiply to negative 24 and add to positive 5, and I think those are, if I negative 24, positive 5, that's 8 and negative 3. Those are temporary factors, so x plus 8 all over 2 over 2. So I end up with x minus 1 is the first one, x plus 4 is the next one, and 2x minus 3 is the next one. And all of that has to be greater than 0. So my zeros of this polynomial function are x equals 1, x equals negative 4, and x equals 3/2. All right, so that's what I'm working with here. That is not my solution. My solution for an inequality is going to be an interval. All right, so let's figure out how to write the intervals. Remember, the first interval starts from negative infinity, and it goes to the smallest 0 there, so that's going to be minus 4, round bracket. Then I'm going to go from negative 4 to the next biggest, which is 1. Then I'm going to go from 1 to 3/2. And then my last one, of course, is 3/2 to infinity. And I'm just going to write my factors here on the left column. So my factors are x plus 4, x minus 1, and 2x minus 3. Okay, I'm going to test now. Pick a number in this interval, minus 100. Minus 100 plus 4, that's negative. Minus 100 minus 1, that's negative. When I multiply a negative times a negative, oopsie, sorry, no, I can't do that. I still have to put negative 100 in here, and that's also negative. And my result, which I'm just going to call p of x. So now these three are being multiplied together. A negative times a negative times a negative is a negative. And I know without graphing that in the interval between negative infinity and negative 4, this graph will be less than 0. Did we want that? We always go back and check what our inequality was. We wanted something greater than or equal to 0, so we're going to say no for that one. Okay, I'm going to pick the next test point. That's going to be 0, and I'm going to put it in here. 0 plus 4, that's 4, which is positive. 0 minus 1 is negative. 0 times 2 is 0, minus 3 is negative. So a positive times a negative, that's a positive. And that's what we want because it says greater than or equal to 0. So that means it's positive. It's a positive number. Okay. Now, a number between 1 and 3/2, that's kind of tricky. So I would suggest you just use decimals here. Turn 3/2 into a decimal, that's 1.5. So a number between 1 and 1.5 would be something like 1.25. So 1.25 plus 4, well, that's a positive number. 1.25 minus 1, that's also positive. 1.25 times 2 is 2.5, and 2.5 minus 3 is a negative number. So a positive times a negative is going to give you a negative. And that's not what we're looking for. We don't want a negative value. Now we're going to go from 3/2 to infinity. So pick a big number like 100. So 100 plus 4 is a positive value. 100 minus 1 is a positive value. 100 times 2 minus 3, well, that's also positive. And when I multiply 3 positives together, I get a positive. And again, that's something that we want. So I'm going to always go back. I always go back and I have a quick look at my original function. I can see that I wanted values that were greater than or equal to 0. So I know when x is 1, when x is -4, and when x is 3/2, I will get a value equal to 0. So we have to be careful with our final conclusion here. I'm going to say, therefore, x plus 4, you can put it in factored form, it's fine. X minus 1 times 2x minus 3 is, oopsie, no, that's the wrong way, sorry, is greater than or equal to 0. Greater than or equal to 0 when I go to my intervals. But I make them square when -4, when my x is between -4 and 1, including the -4 and the positive 1, because when this is -4 here, I get 0. 0 does equal 0. Same with when x is 1. I get 0 here, this whole thing becomes 0, etc. So when x is an element, I forgot that, -4 to 1, and 3/2, so this was another one of our positive results. 3/2 to infinity. Round bracket always for infinity, but square bracket for the 3/2, because if I put 3/2 in here, this factor becomes 0, and 0 will equal 0. Okay, I hope you're following that. The one thing I do want to mention is that you might have noticed a pattern here, alternating. Oh, it's negative, then it's positive, negative, positive. That's not always going to be the case, and I'll just show you a really quick example of that. Just change colors here. So if you have something like, I'll just show you graphically. Oh, that's a pretty color. If you have something like this, then at this 0 here, the graph from -infinity to say -1 was positive. And then from -1 to say 4 here, or whatever this is, it's still positive. So you would get a positive, then another positive in these two intervals. But we break that up because this was an order 2, 0. We have to break it up by the zeros. Okay? So don't always assume there's going to be this alternating pattern. It's not always the case. Okay, so we're going to do a word problem here. Let's just read it. The price P in dollars of a stock T years after the year 2000 can be modeled by the function P of T equals blah, where the price of the stock will be, when will the price of the stock be more than $36? So P of T represents the price of the stock. The T represents the number of years after the year 2000. And it's asking you when will it be more than $36. All right, so this part here is equal to this part here, and this part here represents the price of the stock. So this function here represents the price of the stock. So I'm just going to write that down. And it's saying the price of the stock, we want to find the T value when the price of the stock is greater than $36, more than $36. That's greater than. Okay? Watch your wording, because if I had said, when will the price of the stock be at least $36, you would have put an equal sign with this inequality. If I had said, when will the price of the stock be less than $36, of course your sign would be the opposite. when will the price of the stock be at most $36? You would have less than or equal to. Okay, so the wording can be tricky, so read it a couple of times just to make sure you've got the right sign. Okay, so now I'm going to move the 36 to the other side because, of course, when we're solving, we need to have 0 on one side because we're finding the zeros, remember? Minus 36 is greater than 0. Okay, so now I need to factor this. So what I'm going to do first is I'm going to factor out the 0.4 because I'm going to hope that when I do divide all of these terms by 0.4, I end up with some nice numbers. So it's going to be t cubed minus 11 t squared plus 28t minus 90 is greater than 0. And now I'm going to divide both sides through by 0.4, and I end up with just t cubed minus 11t squared plus 28t minus 90 is greater than 0. So I've in effect just gotten rid of the 0.4. Remember, that number in front does not affect the zeros, so it's not going to make a difference to our solution. Now, I'm just going to pause here and tell you that had this number been a negative, it wasn't, but had it been a negative, and if we had divided through by negative 0.4, you would have had to switch the sign because remember the rule about dividing an inequality by a negative number, the sign switches. Okay, so I just want to make sure you're remembering that because it does come up in word problems sometimes. Okay, I'll see if I can just get rid of the negatives, or the yellow here. Okay, so back to the question. So now I need to do my usual, it doesn't factor by grouping, so I'm going to need to do my usual, oh dear, B, A, no, we don't need the A because our coefficient is 1 here, so we'll just go to B. Oh goodness, what's going on? Why doesn't it? There we go. B equals plus or minus 1, plus or minus 2, plus or minus 3, plus or minus, I think 4 goes in there. No, maybe not. Dot, 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 plus or minus 9, dot, 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 dot. All right, so here we go. It's 9. I'm going to tell you that right now. This is a nasty one where you might be working the numbers for a while before you get to 9. This is not the kind of question I would give you on a test. I would somehow lead you to the number a little more quickly than you having to go through a bunch of, more than a few numbers to get there. So we're going to try P of 9. And so I'm not going to bother. I'm just going to tell you that P of 9 does equal 0. And so we know that t minus 9 is a factor. That's nice. And so then I know now that if I have minus 9 here, I have 1 minus 11, 28 minus 90, bring down the 1, minus 9, minus 2, 18, subtract that, that's 10, minus 90, 0. So far, what I know, I have that t minus 9, almost wrote an X there, times t squared minus 2t plus 10 is greater than 0. Okay, so I have to factor this if possible. And I look at that and I see, I don't think it's factorable. Two numbers that multiply to 10 and add to negative 2. No can do. So I'm going to do my b squared minus 4ac. And I'm going to get minus 2 squared minus 4 times a times c, which is 4 minus 40, which is minus 36, which is less than 0. We can conclude. We can just say something like this: factor has no roots or solutions. And so I know that the only root here, or the only 0, is t equals 9. Okie dokie. Am I done? Did I find the year, the time, the interval when the stock was greater than $36? Well, I found one particular year where it was equal to $36. That was in the year 2009. But this is not our solution. What we have here is we have a 0, but we can have two intervals when we have a 0. So I'm just going to set up a chart here. So my first interval would be the interval from negative infinity to 9. So those are all the years before 2009. And then I'm going to set up another interval for the years after 2009. And my factors are just going to be t minus 9 and t squared minus 2t plus 10. I'm going to have this little, and I'm just going to write p of x, or no, sorry, we didn't give a name to it, and it's not p of x, it's p of t, right? So I'm going to put in p of t, and then I'll just write result, and I'm sorry that this is so messy. Okay, so testing. I'm going to pick a number between negative infinity and 9. How about 0? 0 minus 9, that's negative. 0 squared minus 2 times 0 plus 10. Well, that's positive. And then when I multiply this times this, a negative times a positive, I get a negative. We go back to, I would say go back to here. And is this what we want? Did we want a negative value? Greater than 0 means it's a positive value. So this is not the result we wanted. We're going to go to this one just to double check. You never know. It might all be below the x-axis, but it can't be because it's a cubic function. But anyway, we'll just do our due diligence here, and we'll put in 100. So 100 minus 9, well, that's positive. 100 squared minus 2 times 100 plus 10 is still a positive number. So a positive times a positive is a positive. And when I check against my inequality, I see that, oh yeah, okay, that is the inequality that I'm looking for, or the interval, sorry, that I'm looking for. So now, how to answer this question? The question was, when is the stock price greater than $36, right? All right, so we know that it's the stock price. It has to be greater than, will be greater than $36 after 2009. So the wording is very careful. You have to be careful about this. It's not in 2009, it's after 2009. Okay? All right. Please do your homework for 2.6. That's the last lesson. I do expect you to set the charts up and for all of the solving of the inequalities. I know your textbook does it using cases, and if you refer to that, I'm just going to be a stickler on this one and ask you please to use the chart method, because you will need to use that chart method again in chapter 3. Okay, thank you. Have a great weekend.